Today we will start with surface chemistry. Now we will understand what is adsorption. It is the phenomenon of retaining or attracting the molecules of a particular substance on the surface. This is known as adsorption. The substance which is adsorbed is known as adsorbate और जिसके ऊपर हम adsorb करते हैं उसको हम बोलते हैं adsorbent. Now what is desorption? Removing the adsorbed substances is known as desorption. Now what are the factors affecting adsorption? Now let us understand the first factor, that is the nature of gas adsorbed. इसका मतलब कि different gases will adsorb on a surface to different extent. Then let us say surface area of adsorbent. अब जितना ज़्यादा surface area होगा उतनी ज़्यादा adsorption होगी, because greater the surface area, more particles will get adsorbed on that surface. So that means greater the surface area, greater would be the adsorption. So that means if we are talking about a lump of charcoal and finely divided charcoal, obviously adsorption would be greater in case of finely divided charcoal. Now let us talk about temperature. Now as the temperature will increase, adsorption is going to decrease, because the particles which are adsorbed, they will leave the surface as the temperature is increased. Now pressure. As you increase the pressure, adsorption is going to increase, because more number of particles will get attached to the surface as the pressure is increased. Now let us understand what do we mean by activation of adsorbent. Activation of adsorbent means that we have to increase the surface area of the adsorbent. And how can it be done? It can be done either by removing the gases which are already adsorbed by passing superheated steam, or by dividing the adsorbent into different particles, into large number of particles, we can achieve activation of adsorbent, which is possible by mechanical rubbing also. Now let us understand what is the basic difference between adsorption and absorption. Now you have heard about absorption many times. Now adsorption, as I told you, because the molecules, they are attracted and they are attached on the surface, they are retained on the surface. So we say adsorption is a surface phenomenon. But when we talk about absorption, we say that it is a bulk phenomenon, because the substance, it gets completely retained inside. अब दोनों में difference क्या है? Adsorption में the composition of the substance is not uniform throughout, because the concentration is more on the surface. Surface के ऊपर ज़्यादा है और bulk के अंदर कम है. लेकिन when we talk about absorption, the concentration is uniform throughout. So that means concentration is more on surface, and यहाँ पर हम बोलेंगे that concentration is uniform throughout in case of absorption. Now what is the example of adsorption and absorption when we talk about charcoal? So we say that ammonia gas gets adsorbed on charcoal, but same ammonia gas gets absorbed in water. So these are the two examples which differentiate between adsorption and absorption. Now what is an adsorption isotherm? Now when we plot a graph of x by m versus p, what is x here? X is the mass of adsorbate, m is the mass of adsorbent, and P is the pressure. So, at constant temperature, when you plot a graph of x by m versus P, that is known as adsorption isotherm. Now, there are two types of isotherms which we have to study. Let us first understand the Freundlich adsorption isotherm. Now, according to Freundlich adsorption isotherm, when we take x by m at low pressure, we get x by m is directly proportional to P at low pressure. When we take it at moderate pressure, so at moderate pressure what happens? At moderate pressure, x by m is directly proportional to p raised to the power 1 by n, where n is integer. And when we talk about high pressure, we say x by m is directly proportional to p raised to the power 0. That means it has become independent of pressure, indicating that Freundlich adsorption isotherm is valid or is applicable only at low pressure. It shows deviations at high pressure. So, when we plot a graph, we get a graph like this, and here suppose I have got the saturation pressure. So, that means at higher pressure, now x by m does not depend upon pressure. So, that means it is applicable only at low pressure. Now, let us understand the graph at moderate pressure for Freundlich adsorption isotherm. Now, what will happen at moderate pressure? As I told you, x by m is directly proportional to P 1 by n. When I remove the proportionality sign, I get a constant. Now, when I take log on both sides, so I will get log x by m is equal to 1 by n log p plus log k. Now, when I compare it with an equation of a straight line, that is y is equal to mx plus c, I plot a graph of log x by m versus log p. Intercept क्या हो जाएगा? Intercept would be log k, और slope क्या हो जाएगा? Slope would be 1 by n. So, intercept would be log k and slope would be 1 by n. Now, let us understand the Langmuir adsorption isotherm. Now, in Langmuir adsorption isotherm, there is an assumption that the adsorption is monolayer. Monolayer means a single layer of gas is getting adsorbed on the surface. Now, let us understand the graph for Langmuir adsorption isotherm and the expression for it. So, x by m is equal to AP 1 plus BP. So, this is the expression for Langmuir adsorption isotherm, where A and B, they are constants and they depend upon the nature of gas, the nature of adsorbent, and they depend upon the temperature. So when I plot a graph of m by x versus p, I will have to write it like this: 1 upon a plus, like this I will write. Now when I plot a graph of m by x versus 1 by p, now what is going to happen? If I compare it with the equation of a straight line, the slope would be 1 by a and intercept would be b by a. So this is the plot between m by x and 1 by p. Now x by m upon p would be equal to a upon 1 plus bp. So if I take the reciprocal, it will become 1 plus bp by a. Now if I have to plot a graph, I will write it as 1 by a plus bp by a. And I have to plot a graph of P x by m versus pressure. So now what would be the slope of the graph? It would be b by a. And what would be the intercept? Intercept would be 1 by a. So slope is equal to b by a and intercept is equal to 1 by a. Now let us understand why adsorption is always exothermic. Now what is happening in case of adsorption? पार्टिकल्स या मॉलिक्यूल्स सरफेस के ऊपर रिटेन हो गए हैं, उनकी मूवमेंट कम हो गई है. दैट मीन्स डिसऑर्डर और रैंडमनेस ऑफ द सिस्टम हैज़ डिक्रीज्ड. इसका मतलब क्या है कि डेल्टा एस इज नेगेटिव. नाउ फॉर अ रिएक्शन टू बी स्पॉन्टेनियस, delta G should be negative. Delta G should be negative. Now if we look at the Gibbs-Helmholtz equation, delta G is equal to delta H minus T delta S, तो हम देखेंगे कि अगर डेल्टा S नेगेटिव है और डेल्टा G नेगेटिव होना चाहिए फॉर द रिएक्शन टू बी स्पॉन्टेनियस, ये तभी पॉसिबल है इफ delta H is negative, which means that the process is exothermic. ये तभी पॉसिबल है अगर डेल्टा H नेगेटिव है, और डेल्टा H नेगेटिव होने का मतलब यही है कि रिएक्शन जो है वो एक्सोथर्मिक है. नाउ लेट अस अंडरस्टैंड व्हाट इज फिजिकल एड्सॉर्प्शन एंड व्हाट इज केमिकल एड्सॉर्प्शन. वी आर कंपेयरिंग फिजिकल एड्सॉर्प्शन एंड केमिकल एड्सॉर्प्शन. फिजिकल एड्सॉर्प्शन में क्या होगा कि एड्सॉर्बेट वुड बी गैसेस जो सरफेस पे जाके एड्सॉर्ब हो जाएंगी इन केस ऑफ फिजिकल एड्सॉर्प्शन. नाउ क्योंकि गैसेस एड्सॉर्ब हो रही हैं तो व्हाट फोर्सेस आर इन्वॉल्व्ड? वीक वैन डर वाल्स फोर्सेस. पर केमिकल एड्सॉर्प्शन में क्या होगा? दैट अ स्ट्रॉन्ग केमिकल बॉन्ड इज फॉर्म्ड बिटवीन द adsorbate and the adsorbent. So that means the forces involved are strong chemical bonds. Now because physical adsorption में the gases have to be adsorbed on the surface, activation energy is very low. So we say very low activation energy, or we can say no activation is required. बट हियर क्योंकि यहाँ पर केमिकल रिएक्शन होना है बिटवीन द एड्सॉर्बेट एंड एड्सॉर्बेंट, सो वी विल से हाई एक्टिवेशन एनर्जी. नाउ वी विल से दैट physical absorption is non-specific. Non-specific का क्या मतलब है? That any gas can be absorbed on the surface of an adsorbent. But when we talk about chemical absorption, तो वहाँ पर it is specific क्योंकि a reaction has to take place between the adsorbate and adsorbent, which is possible only if it is specific, because every reactant cannot react with every other reactant. So every adsorbate cannot react with any adsorbent. So that means it is specific in nature. Now physical adsorption is reversible. That is, once the gases are adsorbed, you can remove them. But chemical adsorption is irreversible in nature. Then we say physical adsorption is multi-layer. Multi-layer means that after the adsorption of a particular gas, any other gas can also be adsorbed on the surface. So many gases can form layers on the surface. But when we talk about chemical adsorption, we say that it is monolayer, because once adsorbate has reacted with adsorbent, no other adsorbate now can come and react with that adsorbent. एक बार अगर reaction हो गया तो उसके ऊपर दूसरा reaction नहीं हो सकता. So these are the differences between physical adsorption and chemical adsorption. Now we will understand the adsorption isobars for physical and chemical adsorptions. And then we will understand the effect of temperature on physical and chemical adsorption. So when I plot for physical adsorption versus temperature at constant pressure, as the temperature increases, the gases which were adsorbed, they will start removing from themselves from the surface, that is, they will start getting dissolved. Now when I talk about the chemical adsorption, what is happening? पहले तो adsorption will increase with increase in temperature, क्योंकि हमें activation energy भी चाहिए for the reaction to take place. But as soon as the activation energy has been achieved, now what will happen, and all the adsorbent sites, they have been fully occupied, now it will start decreasing with increase in temperature. So that means for chemical adsorption, it first increases and then decreases with temperature. Now let us understand what are the differences between true solution, colloidal solution and suspension. Now the very first thing is that we can distinguish by the particle size. Particle size for true solution is less than 10 angstrom. For colloidal solution, it is in between 10 angstrom to 10,000 angstrom. And for suspension, it is greater than 10,000 angstrom. So if the particle size is this, now we can talk about the visibility. True solution में the particles, they are invisible. Colloidal solution में we say that they scatter light, that is, they show Tyndall effect. And for suspension we will say that the particles are visible. Now when we talk about the true solution, we say that the particles, they can pass through filter paper as well as animal membrane. They will pass through filter paper as well as animal membrane. Colloidal solution will pass through filter paper, but it will not pass through the animal membrane. And when we talk about suspension, it will neither pass through filter paper because the particle size is large, and nor it will pass through animal membrane. Now when we talk about the transparency or translucency, true solution is transparent colloidal solution is translucent and suspension is opaque. Now, let us understand what is dispersed phase. Now, the substance which is dispersed, that is known as the dispersed phase, and the substance in which it is dispersed, that is known as the dispersion medium. Now, if the dispersion medium is water, so we will say the sol formed is hydrosol or aquasol. If it is alcohol, we will say that it is alkosol. If it is benzene, we will say it is benzosol. And if it is air, we will say, or it is gas, then we will say it is aerosol. Now we will classify the sols on the basis of stability and the interaction between the dispersed phase particles and the dispersion medium particles. Now let us understand what are lyophilic sols and lyophobic sols. They have been classified on the basis of nature of interaction between the particles of dispersed phase and dispersion medium. Now, lyophilic sols can be prepared directly by mixing dispersed phase and dispersion medium. But when we talk about lyophobic sols, now they cannot be prepared directly. They require special methods for preparation. Now lyophilic sols, they are water loving, or we can say they are hydrated. Lyophobic sols are water repelling and they are not hydrated. Now lyophilic sols, they are reversible, but lyophobic sols, they are irreversible. For lyophilic sols, surface tension is low and viscosity is high. For lyophobic sols, surface tension is high and viscosity is low. Than the dispersion medium. Now, when we talk about the stability, lyophilic sols are stable, lyophobic sols are less stable. They are more stable. Now, what is the reason that lyophilic sols are more stable? Now, lyophilic sols are stabilized by charge as well as solvation. What does this mean? That water molecules are surrounding the sol. Now what will happen when we add electrolyte to the sol? The charge will get neutralized. अगर charge neutralize हो जाएगा, solvation is still there to stabilize the sol. But when we talk about the lyophobic sols, it is stabilized only by charge. So that means when the charge gets neutralized on adding the electrolyte, what will happen? There is no solvation to stabilize the sol. So that means lyophilic salts are more stable than lyophobic salts. Now let us understand the classification of colloids on the basis of type of particles, that is multimolecular. First is multimolecular colloids. Now what are multimolecular colloids and how are they formed? जब बहुत सारे छोटे छोटे molecules they aggregate together to form a sol, to form a big molecule which lies in the colloidal range, उसको हम बोलते हैं multimolecular colloid. So that means multimolecular colloid is sulfur sol, gold sol. तो हमने क्या किया, हमने बहुत सारे छोटे छोटे मॉलिक्यूल्स को लिया, एग्रीगेट किया एंड वी गॉट अ मॉलिक्यूल जिसका साइज लाइज इन कोलॉइडल रेंज. नाउ व्हाट इज मैक्रोमोलिकुलर कोलॉइड एंड हाउ इट इज फॉर्म्ड. हमने क्या किया, हमने एक मैक्रो मॉलिक्यूल लिया, बहुत बड़ा मॉलिक्यूल लिया, उसको डिसइंटीग्रेट किया टू फॉर्म अ मॉलिक्यूल विच लाइज इन कोलॉइडल रेंज. मॉलिक्यूल्स बना दिए इसके जो कोलॉइडल रेंज में फॉल करते हैं. दिस इज नोन एज मैक्रोमोलिकुलर कोलॉइड. एन एग्जाम्पल इज स्टार्च, सेल्यूलोस, proteins, they are all macromolecular colloids. Now what are associated colloids? Now the substances which behave like normal electrolyte at low concentration they behave like normal strong electrolyte, but at high concentration they aggregate together to form micelles. They are known as associated colloids, and these micelles they are used in soaps and detergents. We have a cleansing action of soap and detergents, we know that, and we can understand it by formation of micelles. So this is how soap and detergents they clean clothes, by formation of micelles. Now what happens is that we know that there is a polar part in the soap and there is a non-polar part, non-polar hydrocarbon part. So what happens is the polar part it faces towards water and the non-polar hydrocarbon part it faces towards the grease or oil or dirt, and this is how a micelle is formed, and then removal of oil and dirt takes place. Now what is critical micelle concentration? The concentration above which micelles are formed, because I told you कि low concentration पे they will behave like normal strong electrolyte. So that means there has to be a particular concentration जिसके बाद वो micelle की तरह behave करेगा, क्योंकि उससे पहले वो एक normal electrolyte की तरह behave कर रहा है. So concentration above which micelles are formed is known as critical micelle concentration, and the temperature above which micelles are formed is known as Kraft temperature. So this is the temperature above which micelles are formed. Now today we have studied about what is adsorption, the types of adsorption, and we have also studied about the type of colloids. Problems related to these concepts are given in your module. So you will apply these concepts to those problems and you will see that the concept will become more clear. Thank you. God bless you.